I'm Zach Alonso,
And I'm Christian Gerberding.
and our experiments will include Boyle's Law and Charles' Law.
So in our experiment, we will be testing the Boyle's gas law. And this states that volume is inversely proportional to pressure.
So now we're gonna measure the volume and the pressure for the first time of this syringe. So it's clearly 20 milliliters. And the pressure is
105.5 kPa. So now we're going to find the real pressure. We're going to push this up to 10. As you can see, it's 10. And our pressure is around 206.1 kPa.
Now we're going to use the combined gas law, which is P1 V1 over T1 N1 equals P2 V2 over T2 N2. But since we do not have these, we're going to consider them as constants, and we're going to take them out. So that's going to leave us with 105.5, which is our pressure, times our volume, which is 20 milliliters, equals X, which is our second pressure, and our volume, which is 10 milliliters. And we can use these different measurements because it's the combined gas law. So it's going to be 10x, and that equals 105.5 times 20, which is 2110, and then we just divide it. So 2 over 10 equals 10x over 10. So x must equal 2,110 divided by 10, which is 211. And that is in kPa for our second pressure. So our actual pressure was 206.1 kPa, and our theoretical pressure was 211 kPa. So we're gonna do 211 minus 206.1 to get the difference. And that's gonna give us 4.9. And then we're gonna take that, put that over our theoretical 211 and multiply that by 100. So the percent error was 2.32%.
So in our next experiment, we will be using Charles' law. And this law states that temperature is proportional to volume.
Now we're going to take the circumference of the sphere, which will help us find out the volume. So it's about 25.5 inches. And also we're gonna take the temperature. So the temperature of the ball and the area around it is around 20 degrees Celsius. Okay, so now we're gonna do the radius. 25.5 divided by 2 pi, which gives us 4 4.058. And then we'll plug that into here. 4/3 pi 4.058 cubed gives us 4 pi times 4.058 cubed, which is 279.9 inches cubed.
So now we're going to put the ball in the water and then measure the temperature of the water.
This is
Because
pressure.
it's an indirect relationship, right?
But you let some gas go though, so how is that? You are not doing that.
And the temperature of the water is
That's the boil flow is, you're talking about boil flow, pressure boil flow.
60 degrees.
Yeah,
No,
but
boil
what's-
flow.
So we're going to use the combined gas law, which is V1 over T1 equals V2 over T2, and we'll just plug in the variables, which is 279.9 over 293, and it has to be in Kelvin, and that equals X over 333, also in Kelvin, and then we're going to cross multiply to 79.9 times 333 equals 93206.7 equals 293x. So x equals 93206.7 divided by 293, which is 318.1 inches cubed, which is the theoretical volume of the second testing. So now we're going to take the circumference of the ball. And there. So now we're measuring the circumference using this ruler, and it's about 26.2 inches. So the radius is going to equal 26.2 over 2 pi, which is
I have them, let me, their spectroscope and their powers moving.
4.17.
Did you see this one I brought?
And then we're going to plug that in over here. 4 over 3 pi 4.17 cubed.
I will put the,
4 over 3 which is 303.74 inches cubed.
So now we're going to subtract the theoretical and actual yield. So 318.1 minus 303.74. And you get you get 14.36. So now with this number, you're going to put it over the theoretical yield, which is 318.1, and multiply by 100. So 14.36 divided by 318.1 times 100. And you get 4.514%. Thank you for watching.